Students, in this video we are going to discuss about the embedded processors. So the embedded processors are the processors which are being used in embedded systems, especially for the application specific embedded systems. So for all the categories of embedded systems, we are going to discuss the embedded processors. We generally use the embedded processors for specifically for embedded systems design. So the first category will be the general purpose processors. In the general purpose processors, we will be having the microprocessor, microcontroller, embedded central processors, DSP processors, and media processors. And the second category will be the application specific system processor, and the third category will be the multiprocessor system using GPP and the application specific system processor. And the fourth category is application specific instruction set processor, and the fifth one is general purpose processor or the application specific instruction set processor or FPGA core integrated into VLSI chip. That is the ASIC integrated FPGAs, or the in the ASIC integration we may be having FPGA or the GPP cores. So depending upon the application, we will be integrating one or two from this particular list. So we will be seeing one by one. The first one will be the difference between the microprocessor and microcontroller. In the lower classes, we may be studied with a microprocessor and microcontroller. The basic difference between the microprocessor and microcontroller will be listed here. So the microprocessor is a second chip which is supporting the central processing unit, which is capable of doing the arithmetic and all the data path operations, which we may be studied with 8086, 8085 and more Motorola processors. And the microcontrollers will be having the same CPU, and they will be having specific processing capabilities that may be having the RAM, general purpose register arrays, and flash memory, and other input-output ports, and interrupt and timer controllers. And the microprocessors will be having the will be assigned dependent unit, which is having the combinational circuits for interfacing various external world applications. So the microprocessor will be a dependent one, but the microcontroller is having their own ports and their own logics for interfacing with the external world, and they can be interfaced with external interrupt controller, timers, and ERT, etc. for the various functionalities. And the microprocessor will be having general purpose in design, and it may be targeted for high-end markets. So in the recent times also, the processors which are designed for general purpose, and it is separately been designed for embedded also. So for the high-end processors and the high-end market, the microprocessor has been designed separately, and they will be having the limited power saving options. But in embedded side, since we are having multiple input-output ports, and most of the microcontrollers having their rugged 8-bit or 16-bit or 32-bit ports, they will be targeted for embedded markets, and they will be so critical in their power saving applications, and they have been targeted for embedded markets. So these are the main differences between the microprocessor and microcontroller. So we will be seeing what is the general purpose processors which we are using. So the general purpose processors are simple VLSI chip has CPU with data path control with advanced processing units like floating point processing units, planning, and superscale units also. In the recent time processors, we will be having atomic units too. So the microprocessors vary from 8, 16, 32 and 64-bit word length, and with the CISC and RISC architecture. So CISC is going to be complex instruction set computer. They will be dealing with the so-called von Neumann architecture, and the von Neumann architecture means that program and data memory are situated in the same memory unit, so that they will be integrated into a single board, and depending upon the instruction set which the programmer can be modeled, so that particular model is going to be used for the CISC computers. And the instruction sets are very lengthy. They may be limited up to 500 also. But the RISC processors, the reduced instruction set computers, will be dealing with the Harvard architecture. So the Harvard architecture means the program and the data memory are situated in different memory units. So the number of instructions are reduced comparing to the CISC processors because of the presence of the MAC units, that is multiple and accumulate unit. So the instructions are being dismantled as multiple and accumulate operations. So depending upon that particular integration and the denomination, so the number of instructions are being reduced. So if you compare with the RISC processor and the CISC processor, the RISC processors will be having very less number, up to 50 instructions also available in the RISC processor. So the most of the popular microprocessor families are listed here. The Motorola 68HC-XX are coming under CISC, and the Intel 8086 i860 are coming under the CISC. But this Intel i860 can be come with the RISC processor also, because this type of processors will be having both capabilities like CISC and RISC. But the Sun Spark and the IBM Power PC 601, 604 and Motorola MPC 620 are coming with the RISC architecture. So the general purpose microcontrollers are being listed here. So here a diagram has been given as a general functionalities which are available in the microcontrollers. So the general functionalities as such, we can notice that processor and internal RAM, timer and watchdog timer, interrupt controllers and external memory interfaces, and all the input-output ports, the UART and the serial communication ports are available in all the microcontrollers. But for application-specific circuits, the specific version of some of the functionalities has been given here. So they are DMA controller, the network driver, stack interfaces, A to D converter, CAN controllers and PWM circuits, printer controllers, modem, DTF circuits. So these are all for the application specific circuits. For some of the microcontrollers, these circuits are available, so we can use them as we require for the particular application. So we can segregate the microcontrollers as the three main microcontroller families: small scale, medium scale and the large scale embedded system microcontrollers. So eventually the small scale embedded systems consist of 8 to 16-bit microcontrollers. So the main 8 to 16-bit microcontrollers are 8051 and PIC16 F86. So this is a robust one. So since for all the embedded purposes and for all power electronic control purposes, we can use this particular microcontroller because we will be having the inbuilt ADC and inbuilt PWM also. So this Hitachi H8 and 68HC11XX. So this 68HC11XX having inbuilt PWM, so we can use it for all the real-time control of power electronic or the power system circuits. So for the medium scale embedded system 16-bit controllers, we can have a 8051 MX type processor, because this 8051 is going to be a robust and the very low cost processor. But if you are going for this particular 8051, the military applications and all the medium scale very fast processing applications require this 8051 MX processor. And PIC16F876 is a robust one, and it is coming under the medium scale, because comparing this to the 87 series will be coming under the medium scale, because the processing speed is very high. So that the PIC16F8687 will be coming under the medium scale, and PIC18 will be coming under the medium scale, because the 16-bit microcontroller and these kind of PIC controllers having very large amount of ADC and PWM channels, so that we can use it for very large integrations also. And Hitachi D84 D64F 2623 and 68HC12 will be coming under the medium scale. And for the large scale, most of the ARM family controllers will be coming under this particular set. And the Texas Instrument TI TMS 470 controllers will be coming under this large scale embedded system, because these kind of processors will be used in the very high end applications like network processors and the network single processors, and they can be integrated into a very high-end real-time processing units, and for the video processing and audio processing applications too. So for these applications, the embedded systems are going to be a large scale in nature, so that we will be segregating this particular processors into a large scale embedded system. So mainly these processors are coming with 832-bit versions. So next one, we are going to see about the single purpose processors. The single purpose processors are mainly used for single purpose embedded systems, because whenever we are having the very large type of embedded systems, we will be having some of the functionalities to be done in separate processors. Because if you see that some of the processors may be having graphics cards, and they may be having network processings, and they may be having some image processing or video processing applications too. So if you see those kind of systems, if you load the main processors into this kind of very small works, the processor load will be very enormous. So in order to reduce the main processor's load, we will be using single purpose processors for specific processing. So we can see one by one. So coprocessor for floating point processing for multi-rate systems. So especially for multi-rate systems, if you are using the floating point processing units, it is very common to use a coprocessor for floating point processors in multi-rate systems. And the next one will be the graphics processors, because we are having graphics accelerators and the graphics processors and graphics cards for all the laptops and the TVs, whichever we are seeing today. So the conversion between the various formats like GCIF, that is the quarter common intermediate format, that is coming under this 144 cross 176 pixels, and the video frames like 525 cross 625 pixels, and VGA. This is the main video graphic format. So this VGA format will be having 640 cross 480 pixels. So Conversion between these formats will be requiring a separate processor for graphics applications. So for this also we may be having some special processors and pixel coprocessors for using in digicams. So pixel coprocessors needs for converting the raw image into a compressed image like JPEG or JPEG. So we will be using this pixel coprocessor for conversion between the various image resolutions like 2592 cross 1944. So this is a standard one which is used in digicams. So 2592 cross 1728 pixels and 2048 cross 1536 pixels and 1280 cross 960 pixels. This is the standard JPEG format. So conversion between this kind of image resolutions is very much needed in case of digicams and all the camcorders. So we need to have a pixel coprocessor for those kind of applications in order to save the real-time capturing of images and storing in the memory cards. So storing the memory cards in the formats of JPEG is very much essential, so that we will be having this kind of coprocessors. And encryption decryption engines and network processing units, because the encryption and the decryption and will be done in network switches in order to secure the informations whichever we are sharing between the networks. So the encryption is done in the single processors which reduces the loads in the main processors. And the DCT processors for audio and video processing. DCT means discrete cosine transform. So for the video and audio processing, whenever we are capturing the raw images and the raw videos, in order to store them or in order to compress them into a given format or in a given resolution, we need to have some of the compressions and the transformations. So in that scenario, we need to have the discrete cosine transforms. So those discrete cosine transforms can be done in DSP processors. But whenever we are going for the embedded systems like camcorders and digicams, we need to have separate DCT processors so that the load on the main DSP processor or GPP processor is independent and those particular processes won't be getting overloaded. So the protocol stack processes for error detection, the data frames creation and the identification in the network processing units, because for the protocol stacks and all, we need to have separate processors for various protocol calculations in the stacks. So if you have a separate processor for protocol stacks, if those kind of processing will be very fast and very time reducing applications. So we can have this kind of protocol stack processes in network processing units. And next one will be the codec. The codec conversion between the JPEG and the MPEG will be a very common in case of camcorders and the digicams. So encoding the informations and decoding the number of binary data from the videos is very much essential in the video and the audio processing. So this kind of processing will be done for the standard compressions. So in the graphics processors, we don't go for standard processing, because the standard processing won't be required for the graphics processor, because the storage purpose is very less in case of graphics processors wherever you are using. So in the embedded processing and all, if you want to capture the image in the real time and you need to process in the real time, you don't need to store it in a camcorder or in a digicams. So for the real-time processing, so since you don't have any storage purposes, you need to process those images in the raw image formats only. So for that only we will be using this graphics processors, but camcorders and the digicams, we need to store them into a computer retrievable formats. So for that only we need to have this particular codecs. So that only we will be using this codec processors as a different from the graphics processors. And the last one will be the DMA controllers, that is the direct memory access controllers. Since we need to use the processors for the data processing and the real-time processing, we need to have this particular memory controllers into a separate and the independent one. So we need to use this DMA controller for the burst mode and the very fast mode of data transfer between the processors and the memory units. So we need to have this particular DMA controllers in all the embedded and the general purpose computing applications also. So then next we will be discussing about the digital signal processor. Normally these digital signal processors are used with a high precision signal processing with numerous signal processing algorithms like DCT, that is the discrete cosine transform, inverse discrete cosine transform, Fourier transform, and fast Fourier transform, and so on. So in order to process these kind of algorithms quickly, the processor need to have multiply and accumulate units, MAC units. So why we require this MAC units are, these transforms will be having the Tweedale factor. Those Tweedale factors can be found out by the multiply and accumulate type of processing. So if you have numbers of MAC units in a DSP processors, we can do this processing, that is algorithmic processings, very fast and very precise in nature. So for that only we will be having number of MAC units in the DSP processors. So these DSP processors should process high instruction throughput in their processors and with SIMD, that is single instruction multi-data instructions. So what it means is it should have a single instruction. That instruction should handle with the multiple data. So this kind of processing is very much allowed in the DSP processors only. So if you have this kind of processors with this kind of capabilities, the algorithms like DCT and FFT can be done with a 10 nanosecond, that is very least only I am saying, that is 10 nanosecond processing is expected. So this kind of process may have a very large instruction words also. So some of the main and very familiar DSP families are listed here. TMS320C XX families. So in these families we will be having real-time processing DSP processors also, audio and video processors also we will be having. So the source of this particular type of processors are from Texas Instruments, and the SARC type of DSP processors are supplied with the analog devices, and 5600XX are supplied with the Motorola company. So next one will be a very important processor, that is application specific instruction set processors. So these kind of processors are very application specific. So these kind of processors needs tailor-made instruction sets, because in the commercial microprocessors we will be having the instruction sets that are suitable for the general purpose processing only. So whenever we are going for the specific type of processors and the specific type of embedded systems requirements, we need to have tailor-made instruction sets which are derived from the logics which we are studied in the digital logic circuits and all. So if you have those kind of logics for your processors with these specified instruction sets, that will be very fast and it will be very efficient too. So for that only we will be having this kind of processors. They have a minimum instruction set architecture, that is predefined instruction set architectures, and they can be configured with the new instructions that can be configured with using FPGA and the chip synthesis technologies. So using these technologies, we can configure the logics with using the FPGA blocks, and using those blocks we can configure the instruction sets, and we can give very configurable processes for the programmers, so that they can use the flawless operations and the very precise performances also. There are alternatives for the hardware oscillators which are used in the baseband signal processing and the video codings too. So in hardware oscillators, the data paths cannot be altered. So if you are having a hardware oscillators like graphics cards, so if you are having those data paths that cannot be altered. So for this process, that is application specific instruction processors are having their own retargetable compilers. So those compilers can be used for alteration of these data paths, so that you can use any kind of instruction sets whatever you need for your application. So by this way we can tailor-made our instruction set also for a given processor, and you can set on your own goals and you can play on those. Usually the high-level languages based design is preferred for this kind of processes, because the toolset for this process, the design of toolsets is very difficult. So the examples for this kind of processors are ASIP designer for the Synopsys and the Studio for the Codasip. So these are the some of the softwares which are available for the design of application specific instruction set processors. So next one we will be going to see about the application specific system processors. So the processors which are designed for specific applications with a unique set of processing units for specific tasks assigned to the system. So for that we will be having a great example like real-time video processing, where we need to process the video into MPEG-2 or MPEG-3 standard video compression and the decompression systems. So for those standard video compression and the decompression systems, we need to achieve the real-time processing. So for real-time processing, we need to have a GPP. So it is essential, but only GPP is not required. It is not enough. So we need to have a DSP unit in order to configure with the DCT and FFT algorithms. So GPP with an DSP, if you are integrating into an embedded board, is not a economical one, because this GPP will be working working in given frequency, but the DSP unit will be working in a very higher frequency. So matching between these two with a single given embedded board is not applicable. So we need to have this particular integration into a given chip that is configurable by the FPGA and the ASIC processing. So this GPP with an DSP unit can be integrated into a single chip, and these things can be configured and the interfaced with the rest of the systems. So the next example that is going to also be a great example, that is if you are using a network processor So in that network processor, if you are having a specific protocol to be addressed in that particular network, we can install that particular specific protocol with the help of this particular application specific system processor, because those kind of processors can be configured with a specific set of protocols for working in that particular network, using it for encryption and decryption purposes. So those kind of chips are available in the market too. So example is W3100A of I2 chip company, and the another one will be a serial to Ethernet converter IAM7100. So this is a common popular application specific system processor that can be used in the embedded system design. Thank you.